Hello children, how are you? I hope you all are happy and healthy. I also hope that you have practiced the first two methods of solving the quadratic equations. And by now you must have mastered them. Yes, regular practice makes you master of it. We all know, whenever we have to try something new, we always feel afraid of it. Actually, we fear the failure. But that fear lasts only till we actually try that. Yes, it happens with everything. To reach from fear to expertise, we just need to try and practice. And mathematics is also the same. If you want to master it, you just need to keep on trying and keep on practicing. So, let's try the third method of solving the quadratic equation. We call it the discriminant method or the quadratic formula. So, let's see. Now, if I'll start by explaining the formula on the board, it will fill the whole board and you will feel fearful again. So, leave it for now and just see here. X equals to minus b plus minus under root d upon 2a. Now, let us look at all the elements one by one. It starts with x. Now, x is the root, so it means this formula will directly give us the roots. No more calculations, no factorizations, nothing else. Simply putting of the values in the formula and we will get the answer. So, that's a good thing. After that, we have minus b. Now, the value of b we can have from the quadratic equation. To make it negative, we just need to put a sign of minus in front of this and then we will get minus b. So, that's easy. After that, we have a plus and minus sign, both the signs together. Now, why so? This is so because after this, we have under root d. Now, what is d, that I'll just tell you. But under root d means its square root. Whenever we find the square root of a number or a variable, we always get two answers, one positive and one negative. That's why two symbols together. Once we will take it as positive and once we will take it as negative. Right? So, after that we have 2a. Now, the value of a we can get from the quadratic equation and we will just twice it. So, we will get 2a. So, let's look at the d now. What is d? D is the discriminant and its value is b square minus 4ac. So, b square, that is b squared, and minus 4ac. Value of a and c also we will get from the quadratic equation only. So, that's the formula. Now, let's see one example to use it. Let's see how we can solve. So, our equation is 2x square minus 7x plus 3 equals to 0. Now, to solve it, we first need to find out the discriminant, and discriminant is b square minus 4ac. So, here we need the values of a, b and c. Now, a in this equation will be 2, b will be minus 7. We need to take the sign of minus also, and c will be 3. Now, putting these values into this formula, we get b square, that is minus 7 squared, minus 4 multiplied by a, which is 2, multiplied by c, which is 3. So, we will get 7 7s are 49, minus 4 2s are 8, 8 3s are 24. So, 49 minus 24 will be 25. So, value of d here is 25. Now, there is one rule that if the discriminant is a whole number we all know are the positive numbers or 0. So, if the discriminant is 0 or greater than 0, that is a positive number, then we will get two real roots of the equation. Now, here discriminant is 25, which is a whole number. So, this equation will give us two real roots. So, now let us find out the roots. The formula is x is equal to minus b plus minus under root d upon 2a. So, minus b here will be minus 7 because we already have a minus with 7. So, one more minus, when we will multiply these both, we will get the positive 7. And after that, plus minus, once we will take it as positive and next time we will take it as negative. Under root d, the value of d was 25. So, here we will have under root of 25. Then 2 multiplied by a. Value of a is 2 here. So, 7. Now, taking it as positive, we will have 7 plus 5 upon 2 2s are 4. That is 12 upon 4, which is equal to 3. And if we take it as negative, then we will have 7 minus 5 upon 4, that is 2 upon 4, that will give us 1 upon 2. So our two roots are 3, 1 upon 2. So our next example is 4x square plus 4 under root 3x plus 3 equals to 0. Now to solve this, first we need to find out the discriminant. D equals to b square minus 4ac. Here the value of a is 4, value of b is 4 under root 3. I hope you are not afraid of it. There's nothing to be like that, it's so easy. And the value of c is 3 here. Now putting these values, b square, see 4 under root 3 whole squared. We'll do the square of under root 3 and we'll get 3. So it's removed. And then we have minus 4 multiplied by a, that is again 4 multiplied by c, which is 3 here. Now solving this, 3 under root 3 multiplied by under root 3 will give us 3, and 4 4s are 16, 16 3s are 48. Here also 4 4s are 16, 16 3s are 48. So the value of d here is 0. 48 minus 48 equals to 0. Now we know that if the value of discriminant is a whole number, then we get two roots. Here it is 0, that is a whole number. So again we will get two roots. Let's see what kind of roots we get here. So for that, the formula is minus b plus minus under root d upon 2a. Now b here is 4 under root 3. So minus b will be minus 4 under root 3 plus minus d. Discriminant was 0, so under root of 0. Now once we will take it as positive and next time we will take it as negative. But it will not affect because 0 is gonna be 0 only. And upon that we will have 2a. Now solving it, minus 4 under root 3 plus 0 equals to 0 only. So we can simply write 2a. A is 4 here. So that will give us minus 4 under root 3 upon 8. So this will get cancelled and the answer is minus under root 3 upon 2. Now next time if we take it as negative, then the root will be minus 4 under root 3 minus 0. That's also one and the same thing. And here we will have 2 and 4. That is, it will get cancelled and we will have minus under root 3 upon 2. Now look at both the roots. Minus under root 3 upon 2 comma minus under root 3 upon 2. So we have two equal roots. When the discriminant is equal to 0, then we always get two similar roots. If the discriminant is a positive number that is greater than 0, then we get two distinct real roots. Now let's see another example. So now look at this example. If we will try to solve it with the help of factorization method, we will not be able to do it. It will take us forever. So let's do it with the discriminant method. For that we need discriminant, which is equal to b square minus 4ac. And for this the values of a, b and c. A here is 4, b is 3 and c is 5. So putting these values here, b square, that is 3 square, minus 4 multiplied by a, that is 4, and multiplied by c, which is 5, equals to 3 3s are 9, minus 5 4s are 20, 20 4s are 80. So 90 minus 80. So discriminant here is 71, negative, minus 71. So the value of d is negative, that is less than 0. Now our rule says that if the discriminant is less than 0, that is a negative number, then the equation does not have any real root. We do not get any real root of the equation. So our job ends here. We need to stop here and we can simply state that this equation does not have any real roots because discriminant is a negative number. So now let me also show you the formula that you see in your book that looks a little scary. Let's see if it is any different from what we did. So this formula says that x, that is the root, will be equal to minus b plus under root b square minus 4ac upon 2a. It will give us the first root. and for second root minus b minus under root b square minus 4ac upon 2a. It will give us the second root. And if discriminant is greater than 0, that is, it is a positive number, then we get two real distinct roots, two different roots, distinct roots. And if discriminant is equal to 0, then we get two equal roots like we just saw. And if the discriminant is less than 0, that is a negative number, then we do not get any real roots, no real roots. So that's exactly what we did. We used the term d here, d for discriminant, b square minus 4ac, and we also wrote plus minus together. So if we look at this way, then it looks scary, but if we do it that way, then it becomes very easy and interesting. So there is no difference, it's one and the same thing. So children, now let's do some practice of the sums. We will take up the questions from your exercises only. So exercise 4.2, question number 4. It says, find two consecutive positive integers, sum of whose squares is 365. So we need two consecutive positive integers. Now if we suppose the first number to be x, then the second number will be x plus 1, because we need consecutive numbers x and then its successor, that is x plus 1. Now sum of whose squares is 365. So let's square them. Let first number be x, therefore other equals to x plus 1, because we need consecutive numbers. Now the sum of their squares, so squaring them we get x square plus x plus 1 whole square. So sum of their squares is equal to 365. So this is our equation. We can solve it. X square plus, opening this bracket, we will get x square plus 2x plus 1 square, that is again 1, is equal to 365. Now we have 2x square plus 2x plus 1 minus 365, that will give us 364 equals to 0. Now we can take 2 as common. We will have x square plus x minus 182 equals to 0. This 2 will go that side and become 0 only. So we will have x square plus x minus 182 equals to 0. Now we can solve it with the help of factorization method. For that we need the factors of 182. Now 182 dividing by 2 we will get 91. Dividing it by 7 we get 13. So we have 2 into 7 into 13. We need x here. So we can take 14 comma minus 13. It will give us 1. So we can write here x square plus 14x minus 13x minus 182 equals to 0. Now 14x minus 13x will again give us x. So we can express it like this. Now taking x common, x plus 14 and here minus 13. So here we will have x plus 14 again equals to 0. X plus 14 in the first bracket and x minus 13 in the next bracket. Now taking it to be 0, we get x equals to minus 14 and here we get x is equal to 13. Now the question says two consecutive positive numbers. So minus 14 cannot be the answer. So the right answer is x. So first number is x. So second number, that is x plus 1, will be 13 plus 1, which is equals to 14. So our two consecutive numbers will be 13 and 14. That's the answer. Now to cross check it, we can simply do the squares of both the numbers 13 and 14. So 13 squared plus 14 squared should be equal to 365. Square of 13 is 169 and square of 14 is 196. It should be equals to 365. Adding this we get 5 here, 6 and then 3. So 365 is equal to 365. So our answer is correct. So the fifth question is, the altitude of a right triangle is 7 cm less than its base. altitude is 7 centimeters less than its base. So if we suppose base to be x, altitude will be x minus 7. Now if the hypotenuse is 13 centimeter, find the other two sides. Hypotenuse is given 13 centimeter. So first of all, we need to make a rough diagram. Here, this is the right angle triangle. Altitude is 7 centimeter less than the base. Suppose the base is x, so altitude will be x minus 7. Now the hypotenuse is given 13. We need to find out these two sides. Hypotenuse is given and we need these two sides. So we can use Pythagoras theorem here. We know that in a right angle triangle, the square of base plus square of altitude is equal to square of the hypotenuse. So we can write it like this: base square plus altitude square is equal to hypotenuse square. So we can put the values here. X square plus x minus 7 whole square is equal to 13 square. Here we will have x square, here x minus 7 whole square. So x square minus 2ab, that is 14x, plus b square, that is 7 squared, 7 sevens are 49, is equal to 13 square, that is 169. Now x square plus x square will give us 2x square. Here we have minus 14x plus 49 minus 169. That will be equal to 2x square minus 14x and minus 120 equals to 0. 169 minus 49 is 120. Again we can take 2 as common. So we will have x square minus 7x minus 60 equals to 0, or x square minus 7x minus 60 equals to 0. This 2 will go that side and 0 upon 2 will again give us 0 only. Now let's solve it. So here we need the factors of 60. 60 can be factorized as 30, then dividing it by 2, 15, then by 3 we'll get 5. So 2 multiplied by 2 multiplied by 3 multiplied by 5. Now we need to make minus 7. 5 3s are 15, 2 2s are 4. That will not give us the answer. So 3 2s are 6, 5 2s are 10. That will make 4, but we need 7. So if we leave 5 like this, 3 2s are 6, 6 2s are 12. So 12 and 5. That will give us 7. If we take minus 12 plus 5 will give us minus 7. So x square minus 12x plus 5x minus 60 equals to 0. X can be taken as common, x minus 12, and in the next bracket we will have 5x minus 12 here equals to 0. X minus 12 multiplied by x plus 5 is equal to 0. Now if x minus 12 is 0, the value of x will be 12. Similarly here, the value of x will be minus 5. Now we know that these are the sides of a triangle. Now a side cannot be negative number. So our answer is 12. This was our figure. This was 13. This was given x. Now value of x is 12 here. And this was x minus 7. So 12 minus 7 is 5. So the base is 12 here, altitude is 5 and hypotenuse is 13 centimeter. Now we can also cross check it. To cross check it, what we can do is, we know that 12 square plus 5 square should be equal to 13 square. 12 square is 144, 5 square is 25 and 13 square is 169. So adding this we get 169 equals to 169. Thus our answer is correct. So the next question is, sixth question. A cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of production of each article in rupees was 3 more than twice the number of articles produced on that day. 3 more than twice the number of articles produced on that day. So if we suppose the number of articles produced on a particular day, on that day to be x, then the price will be 2x plus 3, right? If the total cost of the production on that day was rupees 90, then find the number of articles produced and the cost of each article. Now, if we suppose that number of articles produced on that day were x, so number of articles is equal to x. Then cost of production per article. Cost of production per article will be 3 more than twice this. That is 2x. 2x is twice of x plus 3. So this is the cost of production per article. This cost of production of one article. Now to get the total cost, we need to multiply this by x, that is the number of articles. So we can write total cost of production. COP is cost of production. For this, we will have to multiply the number of articles with the COP per article. So x multiplied by 2x plus 3. This will be the total cost. So according to question, this is equal to 90. So we can equate it to 90. So x into 2x plus 3 should be equal to 90. From here we get the value of x. Multiplying this, we will get 2x square plus 3x. Now 90 will come to the LHS and become minus 90 equals to 0. So here we can find out the value of AC and B. AC will be minus 90 into 2, that is minus 80, and B will be plus 3. Now 180 need to be factorized. So 180 will give us 90, then 45, then dividing by 3 we get 15, then again dividing by 3 we get 5. Now we need to make 3. So 5 3s are 15, 3 2s are 6, 6 2s are 12. Yes, 15 comma 12. It will give us positive 3. But yes, here minus 12. 15 and minus 12. So we can write it like 2x square plus 15x minus 12x minus 90 equals to 0. Now taking x as common, we get 2x plus 15, and here 6, then 2x plus 15. So the two factors will be 2x plus 15 and x minus 6. Taking this bracket to be 0, we will have x equals to minus 15 upon 2, and here we will have x as 6. Now it is actually the number of articles. Now number of articles cannot be negative, so our answer will be 6. Now to cross check it. So now let's move to the next exercise. It's 4.3. Question number 4. The sum of reciprocals of Rahman's ages in years 3 years ago and 5 years from now is 1 upon 3. So find his present age. We need to find out the present age, so we will suppose the present age to be x. Now sum of reciprocals of Rahman's age. Reciprocal is 1 upon the number. So in 3 years ago and 5 years from now. So let his present age. Let Rahman's present age equals to x years. So his age 3 years ago. At that time it was x minus 3. Obviously, we will subtract 3 from x. So now its reciprocal. Its reciprocal will be 1 upon x minus 3. This is the case 1. Now after 5 years, 5 years hence, that is after 5 years from now, his age will be x plus 5 and its reciprocal will be 1 upon x plus 5. Now according to question, sum of these two, that is sum of these two reciprocals, 1 upon x minus 3 plus 1 upon x plus 5 is equal to 1 upon 3. It is given in the question. So from here we will get our equation. So to get the equation, first we will have to take LCM. So LCM will be the product of these two, x minus 3 and x plus 5. So here we will get x plus 5 plus x minus 3. This you understand? Equal to 1 upon 3. Now solving this, we can simply cross multiply. So 3 multiplied by x plus 5 plus x minus 3. This bracket can be opened because there is a sign of plus here. Will be equal to x minus 3 multiplied by x plus 5. Now solving this, we will have 2x plus 5 minus 3 is 2 is equal to x minus 3 into x plus 5. It will give us x square plus we have a plus bx, that is minus 3 plus 5 into x, and then we have AB. It will be minus 15 because we have 3 negative. So here we will have 3 2s are 6x plus 3 2s are 6, and here x square minus, 5 minus 3 will be 2, so plus 2x minus 15. Now taking this all to that side, we will have x square plus 2x plus 6x will become minus 6x, and then minus 15, and plus 6 will become minus 6, and here we will have 0. Now it can be written as x square plus 2x minus 6x will give us minus 4x, minus 15 minus 6 will give us minus 21. It will be equal to 0. Now we can simply solve it. Now to solve this, we need the factors of 21. We know 7 3s are 21. So we can write minus 7x plus 3x. X square minus 7x plus 3x. It will give us minus 4x. Then minus 21 equals to 0. X common, so x minus 7 in the bracket, plus 3 common, x minus 7 here, equals to 0. X minus 7 multiplied by x plus 3 equals to 0. Now if this is 0, then x equals to 7, and here x is equal to minus 3. Now the age cannot be in negative years, so our answer will be this. Let's cross check it. So the present age is 7, x is equal to 7 years. So the age 3 years ago will be 7 minus 3, which is equal to 4. That is 3 years ago. Now age 5 years hence will be 7 plus 5, that is 12. Now reciprocal of 4 will be 1 upon 4, and reciprocal of 12 will be 1 upon 12. According to question, 1 upon 4 plus 1 upon 12 is equal to 1 upon 3. So let's do it. Here the LCM will be 12, and here we will get 3 plus 1 should be equal to 1 upon 3. So 4 upon 12 should be equal to 1 upon 3. It will get cancelled, and we will have 1 upon 3 here. So 1 upon 3 is equal to 1 upon 3. So that means our answer is correct. So children, this was our chapter Quadratic Equations. Now do a lot of practice of all the 3 methods of solving quadratic equations, and also try to make some tricky questions and play with your friends. You will love it. And we will meet in the next part now. Thank you. Have a nice day.